Hi, my name is Tom Ellis, and today I'm here at DVCon talking about improving verification, predictability, and efficiency using big data. So big data has been a term that's been around for a while now, and we've seen the definition of it shift a little bit over time, but it always comes back to the same three key concepts. You need to capture data, process data, and then analyze that data. So when we talk about big data, one of the things that often comes up is the three V's of big data, or the three V terminology, excuse me. So we have increasing the volume of data that we're collecting, the velocity and the speed of that data movement, and then finally the variety or the range of data and sources that we're collecting that data from. So oftentimes people think that verification management isn't really a space where big data plays. We're not talking about as big of a data. But as I mentioned, that definition has evolved over time. And so now we're not just looking at the data itself, but also the processes, the techniques, and the tools that we're using to collect that data. And that's where we start to get into some concepts like machine learning and being able to actually use that data to predict the outcomes of some of the things that we're doing. And we've seen this used in many industries. We have it used in the entertainment industry where they're trying to dictate what might, or predict what might be the next big blockbuster hit, what might next be the next big music genre. We've seen it in places like the energy industry where they're trying to manage peaks and troughs of power usage so that we can be more kind to the environment. We've seen it in law, commerce, advertising, all over the place. And now we're saying, well, why can't we bring that into the verification space as well? So if we look at a typical verification environment, we usually have a design spec, and from that we derive a test plan which shows the features that we want to try to verify. And then we use some type of regression management system to go off and run those tests, and one of the things we usually end up with is some type of coverage, and that's what we use to tie back to our test plan to prove that we've actually verified those things. But we also have a lot of other data sources. We're bringing in information from bug tracking systems, source code management systems, load sharing systems, and all of that information is something that we can bring together to try to figure out why things are happening the way they're happening and predict what might happen next. So if we look at typically what we get most of the time nowadays is we're looking at things of trends of single metrics. So we may be looking at coverage over time, test pass fail over time, bug churn over time. But what we really want to get into is the ability to be able to look at cross-domain analytics. So being able to, for example, take the coverage for our design and overlay on top of that our bug information. So now I can see maybe I have a block that's 100% covered, but I've never noticed that there's a bug in that particular block. And that might point to an issue of not testing that fully. And so as we start to get in this, we start to look at the intelligence maturity curve for analytics. And what we're talking about here is originally we have descriptive analytics, and that's just what happened. So we get out a report that shows exactly what happened. Then we start to get into the concept of diagnostic analytics. And so this is where we can actually see why did it happen. So we get some data, we can drill down and try to figure that out. But where we really want to get into is this world of predictive analytics and prescriptive analytics. So this is not only why it happened, but why, or what will happen if I change something, and then what do I need to do about it. So we have an example in the paper that kind of talks about how we can take the information from our coverage, from cover points, assertion data, and test pass fail data to try to determine based on a particular cover point being covered or not and a test passing or failing, dictating to us where an error might be in our design. And so again, big data isn't just about collecting the vast amounts of data. It's about exploring the relationships between those different data domains as well, so that we can not only see what did happen, but start to predict what will happen and what we need to do about it. Thanks for watching.